Good morning. Myself Prabha Ranjay, working as an assistant professor in EC department at SNS College of Technology. In this lecture video, I am going to discuss about the fixed point and floating point arithmetic from the Unit 4 finite wavelength effect in digital signal processing. Let I discuss. Yeah, the types of arithmetic in digital system generally depends on the representation of the binary numbers. We know there are two types of representation. First one is fixed point representation, and another one is floating point representation. The arithmetic can also be classified into broad classes. First one is fixed point arithmetic, and another one is floating point arithmetic. The fixed point number system has three types of representation for negative numbers. They are sign magnitude arithmetic, ones complement, and another one is two's complement. The sign magnitude arithmetic is generally avoided in digital systems due to inherent difficulty in handling negative numbers during additions. In ones complement addition, the numbers are represented in ones complement format, and then the addition is performed. The carry generated the addition is added to the LSB, which means least significant bit, to get the actual sum. If the carry is 0 after addition, then the sum is negative, and if the carry is 1, then the sum is positive. Two example of ones complement addition, one with positive sum and other with negative sum. Here you can see add the decimal number is plus 0.375 and minus 0.625 by ones complement addition. Okay, by ones complement addition. First you have to convert decimal to binary format. For first number is plus 0.375, second number is minus 0.375. The decimal, which means the binary format for these two numbers are 0 plus 0.011, and another one is minus 0.101. Okay, next add sign bit. First is positive, another is negative. Negative means sign bit is 1, positive means sign bit is 0. We know. Okay, 0.011, and another one is 1.110, and take ones complement means for negative bit, which means 1 means 0, 0 means 1. So 1.0110 we will get 1.010, and finally we remove the dots. Finally we get the value is 1010, and this 1010 is minus 0.625 value of the binary. But this decimal value, binary value for the decimal number 0.625, and 0011 binary value for the decimal value 0.375. Add these two numbers, we get the 1101, and sum carry is 0, which means sum is negative. Okay, the sum can be converted to decimal. You can see the here end of the, which means above the summary in this page you can see. Okay, this is the ones complement addition, which means first you have to convert binary decimal to binary. For negative number you have to convert decimal to binary, as well as take ones complement for negative number. Add this negative and positive number, which means ones complemented number and positive number. Add, and finally if we get the 0 means the sum is negative. If we will get the 1 means the sum is positive. That's all. Okay. This is the ones complement addition, and another one is two's complement addition. In two's complement addition, the number are represented in two's complement format, and then the addition is performed. The carry generated in addition is discarded if the carry is 0 after addition, then the sum is negative, and if carry is 1, then the sum is positive. Here you can see the examples. Same thing, add the decimal value of plus 0.375 and the decimal value of minus 0.625 by using 2's complement. First decimal plus 0.375, you have to convert binary value and add the sign bit, and finally remove the dot. We will get the 0011 for 0011 binary number for 0.375 decimal value. Okay. Similarly, minus 0.625, which means convert this decimal value converted to binary value and add sign value, and third step is complement the fraction part and add one to LSB bit. Okay. And finally we remove the dot. Finally we get the 1011. Add these two binary values. Finally we will get 1110. This is the sum of the two decimal value, sum of the two binary values, and we will get the 0, which means the sum is negative. Okay, that's all. Okay, this is the two's complement addition. And floating point representation. The floating point representation is employed to represent a larger range of numbers in a given binary word size. The floating point number is represented as floating point number n equal to mantissa m into 2 power exponent value. M is called mantissa and E is called exponent. M should be in the range of 0 to 1. Okay, in floating point representation, both mantissa and exponent uses 1 bit for representing sign. Usually the leftmost bit in mantissa and exponent is used to represent the sign. Here you can see, for example, total is 8 bit. First 5 bit is mantissa and another 3 bit is exponent. Left bit is leftmost bit is used to represent the sign, and other 4 bit are used to represent a binary fraction number. In exponent also same. In exponent similarly, leftmost bit is used to represent the sign, and other 2 bits are represent to binary integer value. Okay, as floating point addition. Floating point addition are represented in desired floating point format. The addition can be performed only when the exponent of the both the numbers are equal. Hence, the exponent of the smaller number is changed to equal the exponent of the larger number, and then addition is performed. In floating point addition, if the sum is in the unnormalized form, then it has to be normalized to represent the proper floating point format. And floating point multiplication, the numbers are represented in the desired floating point format. The product is obtained by multiplying the mantissa and adding the exponent. In floating point multiplication, if the product is in the unnormalized form, then it has to be normalized to represent the proper and floating point format. This is the comparison of floating point and fixed point in a b-bit binary. For example, b equal to 8 means 8-bit binary. The range of numbers represented in list when compared to the floating point representation. The position of binary point is fixed in fixed point representation, whereas floating point representation it is variable. The resolution of is uniform throughout the range. It is variable in floating point. This is the main difference between the floating point and fixed point representation. Okay, this is the difference between the floating point and fixed point arithmetic. Okay, the result is accuracy is less due to smaller dynamic range in fixed point arithmetic, whereas floating point its accuracy is higher due to larger dynamic point. Okay, whereas fixed point the operation speed of processing is high and the speed of processing is low in floating point. Hardware implementation is cheaper in fixed point, whereas floating point hardware implementation is costly. And also in fixed point quantization error occurs only in multiplication, whereas floating point quantization occurs error occurs in both multiplication and addition. These all are the difference between the two arithmetic, which means floating and fixed point arithmetic. Okay, if you have any doubt, you can ask through comment. Okay, we will meet in next video. Thank you.